With a population of over 38 million and a crop yield that ranks first in the United States and fifth in the world, California is one of the most geographically important regions. As a result of the constant demand, California is also the largest consumer of water within America. This water comes from a steady supply of runoff from the snowpack in the Sierra Nevada mountain range. Because the region has a wet and a dry season, the snow that falls in the winter is vital to the water that will supply the area for the entire year. In 2013, the region experienced an exceptional drought that is now carried over for 3 years. In January and February of that year, normally the wettest months of the season, California received just 28% and 15% of their normal respective monthly rainfall, ranking as the driest of the period since records began in 1895.
Normally you can see the water line where it's eroded on the hills and along the dam. And usually we fill up every year except when there's a drought, and it's the third year of a major drought.
Today, the snowpack is at just 5% of the normal level, causing Governor Jerry Brown to put in effect the first form of water reduction legislation in the history of the state.
We're in an historic drought, and that demands unprecedented action. It's for that reason that I'm issuing an executive order mandating substantial water reduction across our state.
The 3-year dry spell can primarily be blamed on a ridge of high pressure called the Ridiculously Resilient Ridge. Ari Mix is a professor in the Environmental Science Department at Santa Clara University.
That is this atmospheric pattern that has been just so unusual in preventing kind of the normal western storm track from reaching California. And so basically most of the moisture has been diverted north of California.
Normally, the North Pacific contains a relatively low pressure ridge that allows for storm systems to flow to the south, carrying precipitation into California. Over the past 3 years, however, this zone of high pressure has forced the Pacific jet stream that carries storm systems to the north, driving the majority of the precipitation into Alaska.
They're used to storms in Alaska, but not like this.
And I couldn't get out of the building because the wind was blowing so hard, so pretty wild and crazy.
The epic storm slamming Alaska's western coast right now is twice the size of Texas.
A possible reason for why the ridging of high pressure is occurring is the uncharacteristic warming of sea surface temperatures in the North Pacific Ocean. The North Pacific Ocean has seen a rise in temperature by as much as 5.4 degrees Celsius in some spots, contributing to the warmest temperatures the area has seen since records have began. Of course, it's important to recognize that warming and cooling in the Pacific Ocean actually isn't that out of the ordinary. In fact, it's a cyclical process that changes on an almost annual basis due to the El Niño and La Niña effects.
El Niño is one of the biggest things because it has worldwide effects. The circulation of the atmosphere in water in the biggest ocean on the planet, and it ends up having consequences globally.
Although it is likely that California is experiencing an extreme El Niño, a 6-page report examining the contribution of the observed global warming trend to the California droughts of 2012 to 2014 suggested these extremes appear very unlikely without anthropogenic climate change. Specifically, the decreasing amount of sea ice as a result of global warming has been directly correlated to the odd events that have been taking place in the North Pacific.
From a kind of fundamentals point of view, if we're putting out greenhouse gases and those greenhouse gases are affecting the energy budget of the planet in a fundamental way, it's going to warm the atmosphere and it's going to warm the surface ocean next. And then on a longer time scale, when the surface ocean starts getting mixed to the deep ocean through things like El Niño, it'll warm the deep ocean too.
Global warming also affects California's water supply on a more micro scale. As was mentioned earlier, California's main source of water derives from snowmelt in the Sierras. Collectively, the snowpack provides a portion of the water for more than 25 million people and more than 3.6 million acres of farmland. With warmer temperatures comes less snowfall and earlier melting periods, therefore reducing the overall amount of water that is accessible by the state.
And unfortunately, because of the very dry conditions that have led up to this survey, a lot of the snowpack is going to soak into the soil. It's not going to show up as runoff. And so the increase in reservoir levels is going to be fairly insignificant.
The first step is adaptation. Adaptation can be achieved by reducing water usage in your everyday lives. Such examples are something as large as taking a shower or even something as small as washing your hands. While Governor Jerry Brown has put an emphasis on water management, such as trying to place a $10,000 fine on the biggest wasters within the state, more legislation must be passed within the state Congress to lower the overall usage.
We also are going to start managing groundwater withdrawal, which I think is really important. Most of the water in the state gets used by agriculture, like over 80%. And a lot of that's really totally unregulated. Like you can pump as much groundwater as you want for watering crops. And so I think we're going to start at least coming up with management plans for that. We're only one of 2 states, us and Texas, that don't monitor or manage groundwater withdrawals.
In conclusion, the California drought is primarily caused by a combination of rising sea surface temperatures in the North Pacific and an uncharacteristic zone of high pressure. While there is still debate among the scientific community whether it is primarily human-caused or not, there is still strong evidence to suggest that there is at least some anthropogenic effect over the strange anomalies that we are seeing in the North Pacific Ocean.